My name is Kefa. I'm going to be doing exercise 1.45. So we are given two vectors, A and B, and we are given the x components and the y components of both vectors. All we are asked is to find the angle between the two vectors. So to find the angle, is the formula we know. The dot product of vector A and B is given as the magnitude of vector A multiplied by the magnitude of vector B cosine theta. And this one, vector A, the dot product of vector A and B is given as AX BX plus AY BY. This is the x components of A, x components of B added to y components of A and B. So in this case, I have these values here. I'm going to go ahead and compute them in, which is going to be negative 3.00 times 2.90 plus 6.60 plus negative 2.10, and this one will give me a total of negative 8.7 added to negative 13.86. When you add this, gives me a total of negative 22.56. So I'm gonna go ahead and find the magnitude of vector A, which is given as magnitude of vector A is gonna be the x component and the y component of vector A squared under the root. So I'm gonna do that. Negative 3.00 squared added to 6.60 squared under the root, and of course this gives me the root of 52.56. Same thing, I'm gonna find the magnitude of vector B, which is gonna be 2.90 squared plus the negative of 2.10 squared under the root, which gives me the square root of 12.82. Therefore, I'm going to apply the formula. So I'll say cosine theta from the top formula here. It's going to be vector A times vector B, the dot product of that, all over the magnitude of vector A times the magnitude of vector B. And this is going to be, so theta itself is going to be the arc cosine, which is of course the cosine inverse of this vector A multiplied by vector B divided by the magnitude of vector A times the magnitude of vector B, which is going to be minus 22.56, which we found on top here, divided by the both magnitudes, which is 52.56 times root of 12.52, and of course gives me an angle of, when I compute this, okay, yeah, this gives me an angle of 150 degrees. Looking at it, if I draw the two vectors, draw my two vectors like this. Sorry, I'm gonna draw it here. If I draw them here, I'm gonna have you see, for vector A, the x component is negative. That means it's gonna come this side. Let's say this is negative 3 in our Cartesian plane, and then the y component of vector A is gonna be 6.6. Let's say it's somewhere here. 6.6 is right here. So if I take that one, this vector is gonna look like that. Might be not straight, but that's vector A. And then if I draw vector B, the y component of the x component of vector B is positive. Let's say this is 2.90, and the y component is negative 2.10. let's say it's somewhere here, 2.10, and of course that vector is gonna come this way. So the angle between those two vectors is gonna be this angle, and if you look at it, it's approximately 150 degrees, and that's it for part A. So I'm gonna go ahead, go to part P, doing the same method. Using the part P, I'm gonna do the same way we did. So I have them written down here. Same way we did part A is gonna be vector A multiplied by vector B is equals to the magnitude of this one, vector A, and the magnitude of vector B, cosine theta. So I'm gonna go ahead and compute everything, find each part. So to find the dot product of A and B, it's gonna be 5.00 times 11.00. Those are x component and x components of A and x components of vector B, plus the y component of vector A multiplied by the y component of vector B, which will be 5 point, the y component of vector A, 5.00 multiplied by 6.440, and this will give me the this will give me at the 62.8. When I do that, it's gonna give me 62.8. And I'm gonna go ahead and find the magnitude of vector A, which is going to be the square root of 2.8 squared plus 5.00 squared under the root. That will give me square root of 32.84. And I'm gonna find the magnitude of vector B, which is gonna be the square root of 11.00 squared plus 6.40 squared, and of course it's gonna give me the answer to be 161.96. So same thing, theta is gonna be arc cos of that one, which is dot product, which is 62.8, divided by both magnitudes of, this is under the root, sorry, so it's gonna be root 32.84 times root 161.96, and which will give me the angle of 30.6 degrees. All right, and I'm gonna go, so that's the end of part P. I'm gonna do part C, the last one. Same thing, dot product of A multiplied by dot product of B is gonna be magnitude of A times magnitude of B cosine theta, and of course this one is gonna give me the dot product itself is gonna give me minus 4.00 times 7.00 plus 7.00 times 14.00 equaling to the magnitude of A is gonna be the root of minus 4.00 squared plus 2.00 squared multiplied by the root of 7.00 squared plus 14.00 squared cosine theta. So if I multiply this is negative 4 times 7 is gonna be negative 28.0, of course, to 3 significant figures, and 7 times 14 is gonna give me it's gonna give me another 28.00. And if so, this one gives me 0. Actually, this one gives me 0. So, and this side is gonna be equal to this times this, and the root is gonna be negative root 20, and this one is gonna be root 196 cosine theta. Well, 0. Now theta is gonna be 0 divided by that, root 20 times root 196, and which one? This is gonna be 0 anyway. So the cos inverse of 0 is equals to 90 degrees. Okay, 90 degrees. So that means these two vectors are perpendicular to each other. Like they form 90 degrees, that means they are perpendicular to each other. So let's say this is B, this is A, they are perpendicular to each other. In vector terms, we would say that they are orthogonal to each other, because they form an angle of 90 degrees. And that's the end of part C, and that's my solution. And comment and question is all welcome. Thank you.